Hello, everybody. This is chapter, 19? Yeah, chapter 19. This is video 3. We're going to make this short. We got to talk about something called concavity. So, boom, boom. Concavity is all about the second derivative. It's about the change of the change, or the slope of the slope. So, we would call a shape like this concave up. We would call a shape like this concave down. In general, a concave up shape, I did not read this before I started talking about this, by the way. A concave up shape, if we were to kind of let rain fall on this, the concave up shape would collect the water, whereas a concave down shape would repel the water off of it and it wouldn't hold it. So a common phrase that people use for this is concave up looks like a cup, concave down looks like a umbrella. So no, it looks like a cup, looks like a frown. So, and it does rhyme. Concave up looks like a cup, concave down looks like a frown. So, and the big thing is, when it's concave up like this, we're guaranteed that Why me? All right, sorry, let's see if I can, I just didn't press hard enough. I don't know. We know that F double prime is greater than 0 to have concave up. We know F double prime is less than 0 to have concave down. So positive, negative, big deal. So let's just jump into it. Oh dear, I watched too much Philip DeFranco. All right, f of x is equal to x cubed minus 3x squared plus 3. So the big deal is if we take the second derivative, so f prime of x is equal to 3x squared minus 6x. All right, and then take the second derivative, 6x minus 6. Oh, that was hard. Okay, so second derivative, we do the same thing that we did with mins and maxes, except we're doing it with the second derivative. We set it equal to 0, and we find something that we call inflection points. So inflection points are where we change from being concave up to concave down. All polynomials are either going to be concave up or concave down, except for at their inflection points. So it's going to be like maybe up and then down and then up. It's like it might be switching back and forth, but it's going to be one or the other. It is possible to be neither, and we'll look at that as well. And when I said all polynomials, excluding straight lines. So straight lines are not concave either way. So set this equal to 0, I'll solve it. I'll add the 6 to both sides. I'll get 6x is equal to 6, so x is equal to 1. So if I go in and I was to do a sign chart on my second derivative, we're going to find out some things about f. So let's see. To the left of 1, 6x minus 6, so I'll plug in like 0. That gives me a negative. At 1, we get 0, and more than 1, we get positive. So this means it's going to be concave down looks like a frown. This one is going to be an inflection point, and this is going to be concave up. These symbols are just for my own reference. So this tells me that f of x is going to be like concave down. It's harder to draw. So like this down frowny shape, and then this uppy smiley shape. So that's the best I got. But we're able to say, hey, I know that it's going to have an inflection point when x is 1. And the word inflection, we talk about our vocal inflection, like here's low inflection to high inflection, right? It's that change in our voice. Well, the inflection is the change from concave down to concave up. So we could say it's concave down from what, negative infinity up to 1, and concave up from 1 to infinity. So I'm just abbreviating because I'm short on space. So I think let's see, we'll do one more, and then we're just going to jump into there's a secondary packet that I have for us today that kind of is going to let us think about everything that we've talked about so far. So f prime here was at 24x squared, oh, this is going to be big, minus 8x cubed, so then f double prime is going to be 48x minus 24x squared. Sure, that makes sense. Because now I'm trying to set it equal to 0 or undefined. It works the same way. We pull a 24 and an x out front. Be left with a 2 minus x. So then the 0 of the first one is 0. The 0 of the second one is 2. So here's x, 24x, 2 minus x. Then we've got 0 and 2. So 24x, well, we got negative, then 0, then positive, then positive, then positive. 2 minus x. 2 minus a negative number is going to be positive, so then 2 minus 0 is still positive, 2 minus 1 is still positive, 2 minus 2 is 0, and then 2 minus a number bigger than 2 is going to be negative. So what does that tell us about f double prime? Well, it tells us negative, 0, positive, 0, negative. It's not guaranteed, but a lot of polynomials have these alternating signs like this. There's nothing wrong if it doesn't happen. It's just very common. So we could say this is concave down from negative infinity up to 0, and then again from 2 to infinity. And we could say it's concave up. Oh, I mixed up my order this time. Whatever. I wrote down first, and so it's up from 0 to 2. I know I'm going kind of quick. I'm just trying to get that basic idea out there. And I'm going to move now to the secondary worksheet that I gave you guys. So there is more that we can do with this. So I might come back to this, but for now I'm switching gears. So bye.